tech tip. This tip is how to use virtual topology for better mesh control. And Matt Mihalik, the screen is yours.
Thanks, Dan. And thanks, everybody, for joining us for today's tech tip. As Dan mentioned, this is how to use virtual topology for better mesh control. And we're going to start off with the simple part that you see on the screen here. You might be meshing this with a default mesh, which is going to generate a tetrahedral mesh, which is certainly fine for some instances. You might be in other scenarios where you want to maybe control the mesh count or the element size or the element shape a little better. So some of you may be using a method inserted on that same part. And what I see a lot of our customers using are the hex dominant method. So we can try that. When we generate that mesh, we're going to get what appears on the surface to be a hex dominant mesh, or a complete hex mesh, so let me put it that way. So this mesh looks very nice, very uniform, but we can use our mesh metrics down here to actually look and see the element quality. And in doing so, we find, as expected at least, that not only are we generating hex elements, but we're also generating tetrahedrons, wedges, and pyramids. And if I refine the axes on this graph a little bit, we can see that we've got a lot of pyramid elements of different element quality scattered throughout usually the interior of the volume. This also results in probably a much higher node count than necessary for most models, so your solution times are going to probably increase accordingly. So the next method that some people might try is, instead of the hex dominant, to use the newer multi-zone approach. And in using the multi-zone approach, we're going to select what are called source faces in basically the extrude direction. When we do that and generate this new mesh, we can see now from our mesh metrics that we have a purely hex mesh. There are no default, no degenerate pyramids or tets or wedges. But we might be a little dissatisfied with the element quality or the uniformity of the mesh, particularly in the regions of this countersink here, down here. So it's this area that we're going to focus on in trying to get a little better mesh control there. And to do that, we're going to use virtual topology. So virtual topology is accessible from the model branch. We have a virtual topology here. And the features I'm going to be using in virtual topology are essentially these grayed out items, like split edge at location and split faces at vertices and hard vertex at location. But in order to enable these, we actually have to pre-select something. So I'm going to go in, grab this edge about where I want to split it, and choose the split edge at location. I'm going to do the same thing on this edge, approximately there, and once again on this edge, approximately there. Okay. Now I need a rectangular patch in here. And the benefits of virtual topology, by the way, are you can do this, as you see, right inside Mechanical. You don't have to go back to the source CAD. You don't have to do any CAD manipulation back there. You can do some of this simple stuff right inside Mechanical. The next one is I'm going to select the face, once again, right where I want what's called a hard vertex. And by picking right here, I can create a hard vertex at that point. And now if I change my selection filter to vertices, I can grab those two and split the face there, grab that vertex and this one, split the face there, grab that vertex and this one, and do one final split. Okay. Now when I modify my source faces inside the virtual topology, or inside the multi-zone control, I'm going to add these to my original source faces. And when I redefine this mesh, we'll get what appears to be very similar to that hex dominant method, but now once again, these are all hex elements and they are much better uniformity on that surface. So that's today's tech tip on using virtual topology for better mesh control. Thanks.